Question 1. Which circuit has a resistance of 40 ohms between the terminals? So the terminals in this one, in this network, is this one, and this one. So what is the total resistance or equivalent resistance for each network? On option A, we have 4 identical resistors connected in parallel, and the result in series with 100 ohms resistor. So the equivalent resistance for this section in parallel, because they are identical, so you just repeat the value of one resistor because they are all identical, divided by the number of resistors, 1, 2, 3, 4, and the result of this plus 100 ohms. 100 divided by 4 is 25, plus 100, and the total resistance for the option A is 125 ohms. So A option is definitely not the answer. B. To simplify this, you can look at this network, those two resistors in parallel, and the result in parallel with those two in series. So let's do by section. 2 in parallel and 2 in series, and the result parallel on each other. So those two in parallel, because they are equal, so you just get 100 divided by the number of resistors, in this case 2, so 100 divided by 2 is 50. And these two in series, you add them, so 100 plus 100 is 200. Okay, so to find the equivalent resistance for option B is the inverse of the total resistance is equal to the sum of the inverse of each resistor of the circuit. Or you can use this. So RT inverse is equal to 50 inverse plus 200 inverse. This third step is a simplified way to do it. So the total resistance is equal to the inverse of this plus the inverse of this, the result you invert. So let's see how we do in our calculator. 50 inverse plus 200 inverse equal, and inverse one more time, 40. So option B is definitely the answer. Now let me look how we can do C and D. So C, we have 2 branches here. We have this branch and we have this branch all by itself. So those 3, they are in series, so we can add them. So that is 60 ohms, and the bottom one is 20. So now we have 60 inverse plus 20 inverse and inverse of all these. And our calculator is 60 inverse plus 20 inverse equal inverse. So this is 15 ohms. Now let's look at the last option, which is D. So we have 2 branches, we have 2 equal resistor in series, 2 equal resistor in series. So to simplify this, we can have 40. We add them, and now we have 40 on this one. Okay, so we don't have to do this equation because they're equal. So what we do here is, when they are equal, make our life so much easier. You just get the value of one resistor divided by the number of resistors. They are equal, 1, 2. So our total resistance here is 20 ohms. So this problem was a good review for you when we have connections of resistors in series and parallel. So we just need to solve by blocks, and you get the final answer. Question 2. The diagram shows a circuit in which the battery has negligible internal resistance. What is the value of the current I? First, let's understand the flow of current in this circuit. So here we have this section, and you have another section here. Let's call these branches. So this is one branch and this is another one. So what happened is that we have a current that is flowing from the battery. It's flowing, the battery is pushing the current. So that's the total current that is going to pass through this battery right here. So when enter this joint, is going to split into two currents. I, that's the one that the problem is asking. And here we have, let's label I1 and these label I2. It's easier to understand how things come together. So then this current flows through this resistor of 6 ohms, and right here on this joint is going to recombine with the other current, and I1 plus I2 is going to form IT. So there is a conservation of charge in the circuit. First, let's find the total resistance in the circuit. So now we have those two here, 6 and 3 in parallel. So we have this partial one here is 6 plus 3 and inverse of this. So this is 6 inverse plus 3 inverse. The inverse of this is 2. So 2 ohms right here. And this is 2 ohms. So my total resistance in this circuit, because this is now in series, is 4 ohms. Okay, now that I simplify this circuit to this and finally to this, so now I can calculate my total current. So my total current in this case is total voltage divided by total resistance. My total voltage provided is 12 volts. My total resistance is 4 ohms. So my total current that is flowing through the battery is 3 amps. So after that I calculate the total resistance of the circuit, which is 4, and the total current. Now I'm going back to my original circuit. So my total current here is 3 amps. Now following the sequence, first we found the total resistance, and then we found the total current. So now let's take a look at how this voltage is being split between those resistors. So understand one thing, the value of the voltage is constant. So the voltage is kind of the energy that is providing to the circuit. So each resistor is going to take some of the energy for themselves. So the energy or the voltage is not gonna go higher or lower than is being provided. but the way that is going to be split in the circuit is going to depend on the value of the resistance. Now you may be asking, what this shoe is doing here if you have 6 and 3? Okay, so that's what's going on. In this branch right here, those two, they are in parallel, which means that the voltage on across the 6 ohms resistor and the voltage across the 6 ohm resistor are the same. So the voltage on both is the same thing. So what I'm gonna do is just find the equivalent of 6 and 3, which is I did right here, 2, and 2 is the equivalent for both, so I keep right here. So this is, I just kind of found the equivalent for these two resistors in parallel, and I kept the one that is in series right here. Since those two resistors have the same value, so the value of the voltage is going to split equally for both because they are the same value resistors. What that means is the 12 volts, here will be 6 volts, and this will be 6 volts. What it means is that if I have a voltmeter and I place the probes right here on this section or on this section, I'm gonna read 6 volts. Likewise, if I take the terminals of the multimeter and place right here, I will be reading 6 volts. So the current I1, the one that the problem is asking, is using Ohm's law, is the voltage on across this resistor, which is 6 volts, over the value of the resistor, which is 6 ohms. So my current is 1 amp. To check if this result is accurate, let's calculate the current I2 over the resistor 3 ohms. So it's the same formula like I did here, voltage over the value of the resistor. So the voltage on this is 6 volts over 3 ohms. So I2 is 2 amps. But I still don't know yet. But I do know that my total current is 3 amps. So right here on this joint, the currents that enter is equal to the sum of currents that leave the joint. So here we have IT is I1 plus I2. So my IT is I1 is 1, I2 is 2, so is equal to 3 amps, which is the same value of the one that I calculate using a different way to solve this. Before I leave this problem, I just want to show you that you could skip this step right here to find the total current. You can skip this step, you can skip this step too. And you could just from here, from the diagram that was provided, find the equivalent, and understanding that the voltage, the 12 volts will be split between both because they are equal. Now that you have 6 volts, you can easily calculate the current the problem is asking without going through all these. But that was a good review for you. If the question is asking more detailed type of problems. 3 resistors of resistance R, 2R, and 3R are connected in parallel. Using I to represent the current through the resistor of resistance R, which rho represents the relationship between the currents through the resistors. Number 1. Since all those resistors, they are connected in parallel, the voltage across each one of those resistors is the same. From Ohm's law, the relationship between voltage, resistance, and current is given by this formula. So the voltage here is constant. So the product between the resistance and the current must be constant, which means that if the resistance increases, so the current is going to decrease with the same proportion. So for the resistor R, the current that is flowing through it is I. If the resistance double, so the current is going to be half of. If the resistance triple, so the current will be 1/3 of the original value. So B is the correct answer.